Hi everyone, good evening one and all. So I welcome you all for the live session of the course Renewable Energy Engineering, Solar, Wind and Biomass. We have collected, here I am with Ms. Varna, the teaching assistant of this course. So here we have collected all your queries, general subject related queries, and then some of you requested to redo the problems whatever asked in assignment 1, 2 and 3. So first we are waiting here to get your queries. Till then I would be solving the assignment solutions whatever we asked in your assignment 1, 2 and 3. Also kindly note that here I am going to answer your queries related to solar energy as well as wind energy, and biomass energy systems were handled by Professor Gaur. So he would be meeting you in live during the first week of March. So if you have any more exam related questions, I would also join him to answer your exam related queries, because that would be somewhere near your exams. So we both would answer your queries if any of your queries contain solar energy as well as wind energy. Otherwise this would be my one and only live session. So I would be doing the assignment problems. By then if you have any more queries you can post it here. And also we have collected other your subject related questions, so that also I'll try to answer. The first one is assignment 1. Question number 12. So that is about calculation of daylight hours. So as told in the lecture, the daylight hours can be calculated using S-maths. The formula would be 2/50 into omega S. So this omega S is hour angle during sunset or sunrise. So that is calculated using the formula cos inverse of minus tan phi into tan delta. So this delta is declination angle. This is calculated using delta as 23.45 sine of 360 upon 365 into 284 plus n. So this n is nothing but day of the year, right? So in the problem it was given as July 1st of non-leap year. So that is to calculate February, right? So if you calculate n, January 31st, February 28, March 31st, April 30, May 31st, June 30 and July 1st. So it would be 182. If you substitute n as 182 here, what you would be getting is delta as 23.12 degree. And in the problem itself, the latitude is given phi. So that is given as 34.08 degree. So first you is supposed to convert this degree into minute, 34 degree 08 minute. First you supposed to convert this minute into degrees and then add it with 34, and finally what you would be getting is phi as 34.133 degrees. So if you know delta, if you know phi, then your omega S is done, which is nothing but cos inverse minus tan of 34.13 into tan of tan phi tan delta. So that is 23.12 degree. So omega S is coming around 106.82 degree. So once your omega s is done, then you substitute in S max value 2 upon 50 into omega s, which is nothing but 2 upon 50 into 106.82. So which is coming around 14.24 hours. So in that option D. Okay, so and then most of you asked about the assignment 2 only, because the change probably you confused with this, the number of glass covers, because in lecture 3 practice problem I have done it with one glass cover. So in the question it was asked us number of glass covers 2. So then there was a little change in the formula. So I am not going in detail because all the formulas were given already in lecture 3 practice problems. Only where the change is there, and I will try to substitute the values, and you can redo it as a home task with these values. So the first one is theta r. I am directly writing the formula. So sine inverse of sine theta I, which is nothing but incident angle, upon n2 upon n1. So this is nothing but refractive index of the glass with air. So theta I is given as 15 degree. So this ratio is given as 1.452. So if you calculate theta r with this, then it is coming around 8038 degree. So once theta r is done, so this is probably the 5th question, right? Because the 5 to 8, it is a continuous question. So probably you would be using this for 6, whatever you calculate for 7, like that, right? So 5th question is theta r. So option is given as A. So this probably most of you have done. Then the 6th one, so that is nothing but tau based on reflection refraction component, right? So that is theta r. So if you remember that theta r contains two components. One is theta r1 and another is theta r2. The average of two to be taken. So to calculate tau r1, what you probably require is rho 1, and to calculate tau r2 you would require rho 2, right? So these are all nothing but reflectivities of two components of polarization. So for all these terminologies you please go back and refer lecture 3. So here I am doing only because many of you asked. Right, the rho 1 already formula is there. So sine square theta r minus theta I upon sine square theta r plus theta I. So if you substitute sine square theta r, we calculated as 9.8038. Theta I is given as 50 divided by sine square 9.8038 plus 15. So this value is coming around 0.0466, and then from this you will calculate tau r1, which is calculated using the formula 1 minus rho 1 divided by 1 plus 2m minus 1 rho 1. So this is where probably most of you have done wrong, because during lecture I have done 1 minus rho 1 upon 1 plus rho 1, because this m is nothing but number of glass covers. So since it was single glass cover system, I considered 2 minus 1 is 1. So I have considered the formula 1 minus rho 1 upon 1 plus rho 1. So here we have considered two glass covers. So 1 minus 0.0466 upon 1 plus 2 glass cover, 2 2s are 4, 4 minus 1 is 3, 3 into 0.0466. So this value is nothing but 0.8365. So the similar way you can calculate rho 2. So the formula is tan square theta r, I am directly substituting 8038 minus 50 divided by tan square theta r is 9.8038 plus 15. So if you calculate, rho 2 is coming as 0.0389. So from this, if you calculate tau r2, which is nothing but 1 minus rho 2 upon 1 plus 2m minus 1 into rho 2. So this value is 1 minus 0.0389 upon 1 plus 3 into 0.0389. So tau r2 value is 0.8607. So tau r is nothing but tau r1 plus tau r2 upon 2. So if you take a average of 0.8365 plus 0.8607 upon 2, so what you get is tau r is 0.8486. The option is B. So and then this is the 6th question. The next one is 7th one. So there also only the formula is different. So this is e power tau a. We asked you to calculate transmissivity due to absorption. So the formula is e power minus m k delta c upon cos theta r. What is this m? M is again number of glass covers. Probably you might have missed that. So e power 2 glass cover system, and k was given in the problem as 10, and delta c is thickness. It was given in mm, so you are supposed to convert into meters, and cos theta r already we know 9.8038. So if you calculate, tau a is coming as 0.9315. So the option in the problem is D. And then the 8th one. So 8th one is asked as transmissivity absorptivity product. So tau alpha, which is nothing but tau alpha p upon 1 minus alpha rho d. So all the values are given, but we are supposed to find out tau. Tau is nothing but tau a, tau r. So you have already tau a, tau r already I have done. So I am directly giving you the answer. So 0.8486, which is equivalent to 0.7905. So if you want to calculate tau alpha, 0.7905. Alpha is given in the problem as 0.94. 1 minus 0.94. Rho d is also given as a 0.21. So if you calculate, it is 0.7526. So the option is C. Okay. So and then assignment 3. Right. So in that, question 7 and 8, probably most of you have done correctly, I guess. I didn't get any. Question number 7, I got a few queries. So the question asked was total energy calculation in megajoules. So the energy is nothing but M into HF minus HI. So M is already given as 1.5 10 to the power of 5 kg, and HF is given as 760 kilojoules per kg, and H I is given, which is nothing but 500 kilojoules per kg. So you can calculate by substituting this 1.5 into 10 to the power of 5, 760 minus 500. So if you substitute, what you would get is 390 into 10 to the power of 5 kilojoules, or you can write it as 39 megajoules, because 39.0 into 10, so 10 into 10 to the power of 5 is 10 to the power of 6, that is megajoules. So you might be wondering why then there are a lot of data given. So this also can be calculated by MCP del T. So if you know the temperature difference, Cp is given for that temperature range and mass is given, one can calculate using this as well. So anyway, the enthalpy value is directly given, you can calculate, or one can calculate using MCP del T as well. So for that is the reason Cp value, temperatures were also given as a additional data. And then question 8. So this is very straightforward. So net present, okay, so this is option as A. And then N, that is NPV, net present value, that is minus initial cost plus number of years into annuities plus salvage value. So all the values are straight away given. So you are supposed to substitute all of them, equal to minus 70 lakhs plus number of years is given as 15. So this is 14 lakhs, and then salvage value is given 3,50,000. So if you calculate all of them, what you would be getting is 1.43 crore. So this is given as option B. So otherwise all are MCQ questions, and there was no indirect question, everything is direct, and you can very well get it from the lecture itself. After that I will answer your queries whatever posted in the discussion forum. Those were subject related questions, so I want here to explain so that everyone would be benefited. So one question is, during summer wind blow from South India toward North India due to uneven heating, and if fluid mechanics logic is fine, I have understood this phenomena because fluid always flow from higher potential field to lower potential. So what is the reason behind wind blowing in winter season from North India to South India? So irrespective of the regions, because in India you will have diversified monsoon winds, right? But you can refer very well in solar energy utilization video. So there it is given as differential heating only is the reason for this poles to equator as a global circulation, and land to lake or water side, and mountains and valleys as a local air circulation. So one thing you are forgetting here is fluid, whether you meant as a liquid or air, or the gaseous phase, right? Air. But even then, even in liquid, there is another factor you must to see is density, right? So wherever the temperature is high, the air is getting heated highly compared to the lower temperature region, because of which your density becomes low, and then the pressure also decreases. Due to this pressure difference, the convective circulation, so that means the warmer, less dense air rises up, and the cooler and heavier air try to fill that place, right? So this is the reason for the air motion as well as wind creation. So the same thing is happening during winter season. The second question is, if we can extract energy from electromagnetic waves, then what is the type of energy? So that is nothing but electromagnetic radiant energy. And then it is not clear to me, nuclear energy clean with no emissions. Yes, of course, but isn't it renewable if we used uranium in the seawater? But the thing is, uranium here is considered as equivalent to coal or petrol, because when you are using it, it will deplete one day. So that is the reason behind it. It is put it in a non-renewable energy source. And then another question is, yeah, good one. Thank you for your attention and bringing to my notice. Here it is, I think, Parv Pandya 30@gmail.com. So he closely followed and probably done this problem as well. So he has told that you somewhere used old deviation angle. So it is in lecture 3 practice problems at time stamp of 33.51. So there I was calculating our angle, which is equal to cos inverse of minus tan phi tan delta. So the phi value is 19.28, but delta is 9.42, right? Probably we were calculating the extraterrestrial radiation. So there we supposed to consider April 15th instead of April 1. So when you consider different day, the deviation angle was changed. Angle was 9.42. But while I was substituting as a 4.02, probably the April 1 deviation angle. So he pointed out correctly, but however answer is not changing. While substituting, instead of 4.02, instead of 9.42, I substituted as 4.02. Anyway, I will talk to our editing team and I will edit that and then re-upload the video. Thanks, Pav Pandya 30@gmail.com. And then another a student also pointed out another thing. So it is in lecture 8, solar energy utilization method, time stop at 22. So he was telling minus 7000 plus 15 into 1050 is supposed to be 8750. Yeah, I have done mistake, but if you see 26.01 time stop, I have corrected myself in the video itself. Thank you, Saurav, for such attention to find out mistakes. And then there were two suggestions probably. One is due to fast, I am unable to understand properly. Probably the amount of content we wanted to give for this course, we were rushing up. But however, after seeing this comment, I myself corrected this. Hope in the wind energy you won't be getting such kind of problem. And then another suggestion is, I am using my smartphone to attend the class. We are getting small screen, very difficult to read small words. So I try to put it in, I try to take this suggestion also later slides. And another common query is provide the lecture material. So this I provided the answer in discussion forum as well, and I replied individually to all authors. The thing here is, we sometimes used certain unpublished data, research data, to explain you the concepts better. So because of that, we might not be able to provide all lectures whatever we used for teaching, right? So, and also I told that this is not a web-based course, this is video lecture-based course, but we do consider the students' difficulty. Sometimes the video may not download properly, or you might be facing issue. But my request is, kindly follow the lectures, and also as far as possible get the reference books and try to see beyond that, because when we prepare, if you see any reference book, it is minimum of 300 to 400 pages, right? So for this course, we are giving you 20 hours lecture, right? We may not give you all the essence of that, but when you have this habit of reading through books instead of reading from the slides, you would get in depth of the subject. That is request, and we will try to remove such slides where we have certain data and copyrighted material. and watermark our slides, and we will provide. But please note that there may be discontinuity between two slides, so that please excuse us for that, right? So we may not be able to provide all the materials. Our PPT form also we may not be able to provide. We will have all watermarks because of copyright reasons. We ourselves have personal experience that previous slides were used here and there, so we were we are bit conscious about such copyrighted issues. So that is the reason. Otherwise we finish the course, we will try to do transcripts as soon as possible. This I posted already. And then there is another query related to exam, whether you would provide all the datas. Yes, we do provide. So this course is not meant to mug up anything. Always all my courses are like that. So when you are provided the data, so based on your understanding of the subject, how you are doing the problems. So we would be providing you formula sheets, because it will be very difficult for anyone to remember all such correlations. And even for this formula, deviation angle 23.45 and 284, why would one mug up those numbers? We would be providing you the formula sheet, but remember the notations, because if we want to give every notations, because what is N2, what is N1, what is 284, what is delta, if we want to give all those explanation, it would be very difficult during exam. And even to look at the formula sheet with such big explanation, it would be difficult for you. So because of that reason, we would provide you formulas, but the notations, whatever used in the course, you supposed to remember. Delta means it is a deviation angle, or omega S means it is a hour angle during sunrise or sunset. So those things, N1 means what, N2 means what, theta I means angle of incidence, U is V infinity is free stream velocity. Those things you supposed to know based on the course, whatever you learnt from the course. So all the notations were based on the course, whatever you learnt in 20 or 30 lectures. And also formula, we won't be providing first question you use this formula, second question you use this formula. We would be providing collectively all the formulas. There may be here and there, so you supposed to know which formula to be used for which question, and all the notations are whatever we followed in the course. Okay, so these are all 2 points related exams. One is formula, whether you would provide, and the data, all the correlations, everything we would provide. It is what we require is just your understanding about the subject and how to do the problem. And also remember, we spent almost, in my course I am talking about, Professor Gaud would address you in March first week or second week. And whatever I considered in solar energy and wind energy, so I would be providing all the details. And then remember, I spent almost 3 lecture hours for problems, so you would be expecting problems as well in your final exam, so do prepare for that. So now I will try to see what are all the questions you have asked. So one is, ma'am, how to score maximum marks in this course? So that is by doing all the lectures and understand the lectures. If you have subject related queries, try to contact the course instructors and try to clarify your doubts. And if possible, do get reference book. I already posted in the discussion forum. So almost 70% of this course content you can get from Professor Sohatmi's book itself. So do all those things. That is the only way to score maximum. I hope I answered. Kindly provide the lecture notes. I already answered. It will be good if you provide the class note. I already answered. Give your email ID, ma'am. So this is, you can see it in every lecture. In the first page I have already given, and my TA's mail ID also given. Other than that, you can find me in IITG website, Department of Chemical Engineering. My name would be first. You can find it over there. Mention few research topics in renewable energy. Everything is research topic only. Because I even try to address all those things in each lecture itself. The non-concentrating collectors still are unexplored. because of this orientation and then tracking the sun, etc. And wind energy is not that explored, and there are many possibilities to design a system wherein you can extract maximum possible efficiency of that, close to 60%, etc. And how to minimize this transmission system losses so that you can gain this one. And if you have further interest, you can write to me personally. We will discuss over there, because this may not be of interest to many people. And ratio of theory and problems, ma'am. So that is what I'm telling. Out of because I have taken probably more lectures, my contribution was 10 lectures, but still we have done extensively so that you would get essence of that, because the many courses the problems may not be addressed that depth. That is what we have taken. So 1/3 of my course was problem, right? If you consider this altogether 10 lectures, I have done almost 3 to 4 lectures as a problems. So you may expect 1/3 as a problem and 2/3 as theory. So it is not a hard and fast rule. So this may go here and there. For example, 1/3 may go to 0.33%, may go to 42, and that 0.66 may be even reduced to 0.6 as well, right? And then exam questions will be objective only. Yes, of course, objective type questions only. So we are waiting here. If you have more questions, tell me. Reference book. Reference book I already told. Professor Suhatme's book for solar energy and wind energy. I followed this book extensively. And other than that, there is a book called Manual. I have probably this week onwards, coming Monday, you would be having your wind energy first 2 lectures of basic types, terms and theories. In that, I have given other 2 references for wind energy. For my courses concerned, I taught you solar radiation, and then solar collectors, and solar utilization and storage, and then this wind energy. So for all 3 topics, Professor Suhatme's book is more than enough. And then if you want to in-depth learn things about wind energy, then you can follow I think Professor Manual book that I have given in the reference section. So these 2 books would be fine for solar and wind energy. And also some of you asked the what is that, PDF version, so that we don't have, and also this is against a copyright issue, so you should own a book. And then anything else, and for a few correlations I have given journal papers as well where from that correlation is taken. But if you have access to those journals, you can read, because someone asked about research topics, right? So how they have done, because if someone is not doing it, comparing the experimental data with the modeling data and come up with such correlations, it would have been a little difficult for us to calculate things numerically. So if you contribute in that side also, it would be better, right? If any more queries, you can post it here. Okay. Actually, Ms. Verna wanted to tell you all that the assignment solutions were already uploaded in the Google Drive. You may refer it, and today I also did it, all the problems. Then you might want to refer. You would like to say them hi? Yeah. So Mr. Mrinal, another TA, he is busy with his thesis. So, she is supposed to come here. She is Ms. Verna, so hello. She is helping in all assignment solutions, etc. So you can write to her also. Her mail ID is also given, and you can write to Mr. Mrinal as well. So he is not here today. So she is working on refrigeration systems, refrigeration and air conditioning systems. So she is comfortable in all thermal calculations. Okay, so and there were another queries you did exclusively for exclusively for this live session you posted. So the one is please state your will the data values and formulae for solar collectors, Nusselt number relation, collector plate, I already answered. It is not only the data, even we provide the formula, but not exactly under each question, but it will be a pool of formulas. You are supposed to pick it from there. And then wanted to learn more about renewable energy, you are more welcome, right? So you can learn at any point of time. So if you have further more queries, you can write to us, both to me or Professor Gaud. And then study materials were provided, easy for us to prepare final exam. I told why it is getting delayed, and also you would not receive in total in whole, but we will try to provide as much as possible. And then in week 2 assignment, can you provide detailed solution? I have done today in this live session. And in 5th assignment, I want a complete solution question 10. So 5th assignment was given by Professor Gaud. I may not be knowing. So he is going to address you in another 2 weeks. So there he would do, if you still want. And I'll check with TAs, his TAs, whether that solution is uploaded in G Drive. Ma'am, can you kindly provide with transcripts or PDF of slides? Transcripts we supposed to work in 2 weeks, and this slides for my course, for my lectures solar and wind, I will try to provide in maybe 3 or 4 days after removing certain things. So that's all exclusive questions for live session. So if you have to say something, you can do it. Okay, so we will wait for another 2-3 minutes. If you don't have any more queries, then we would like to wind up the live session. Also, I would like to I would like to thank again CET and the entire office and project team for their cooperation throughout the course, and also I would like to thank Professor Gaud, who is the co-instructor of this course, for all the discussions and organization of lectures. And also I would like to thank my 2 TAs who helped me in preparing PPTs as well as the assignment and solution. So I'll wait for 1 or 2 minutes. Okay, so if there are no more queries, we would like to end this session. And once again, wish you all success for your exams, and try to register, and maybe it would be a self-check, right, how much you learned in this course, and appear for exam. So wish you all success. Thank you. Thanks a lot. Thank you.